Car factories today look like something out of a futuristic movie. When you step inside, you see enormous robotic arms moving with perfect rhythm, welding glowing sparks onto car frames, while human workers stand nearby inspecting details that machines still can't handle. It's a choreography where humans bring precision and judgment, and machines provide tireless strength and speed. The idea of mass assembly lines started with Henry Ford's Model T in the early 1900s, when the concept of dividing production into small, repeatable tasks completely changed manufacturing. Today, that principle still exists, but the scale and technology look like science fiction. Modern factories use thousands of sensors and cameras that guide robots as if they were performers on a stage. The painting process is especially mesmerizing. Robots coat a bare metal frame with layers of color in seconds, creating a perfect surface without a single drip. Then humans step in to handle tasks like fitting delicate wiring, adjusting interiors, and giving final checks that require flexibility and decision-making. This combination makes the process more efficient and also more reliable. For example, Tesla's gigafactories use robots that can lift entire car bodies with ease, while specialists ensure every panel aligns down to a fraction of an inch. What once took weeks is now reduced to hours. To watch a car come together from a pile of metal sheets into a fully functional machine feels almost like watching a giant puzzle assemble itself. Some experts even compare it to a Marvel movie sequence where technology seems alive, moving in perfect sync to create something extraordinary. The balance between robotic muscle and human insight keeps car production both futuristic and very human at the same time. Seafood processing plants are places where you can see some of the most fascinating techniques in action, and octopus preparation is a striking example. When the catch arrives, it doesn't go straight to the dinner plate. It goes through a carefully designed process where both tradition and technology come together. First, the octopus is cleaned with precision. Workers wearing gloves handle the arms and body, making sure every part is ready for the next stage. Then comes the tenderizing. Unlike fish, octopus meat has unique fibers that can be tough if not treated properly. Specialized rotating drums and gentle massaging techniques are used to make the texture smooth and delicate, which is why dishes in restaurants feel so refined. Afterward, the octopus is often blanched in hot water to firm up the surface and preserve the bright colors of the skin. This step also makes it easier to package without losing freshness. The arms, with their distinctive rows of suction cups, are arranged in trays or vacuum-sealed packs depending on where they're headed. Some parts are kept whole, while others are cut into even slices for quick cooking in kitchens around the world. Factories that handle this process often look more like laboratories than seafood markets, with stainless steel equipment, chilling systems, and strict hygiene controls. What makes it especially mesmerizing is the visual. The arms spread out neatly like spokes of a wheel, ready for preparation. The final result is not just about food safety, it's about transforming something straight from the ocean into a product that chefs can turn into gourmet dishes. It's an industry that bridges ancient fishing traditions with modern precision, and watching it feels almost like a behind-the-scenes scene from a culinary documentary where every step is tuned for perfection. Neon signs are more than glowing advertisements. They're living art created through a process that feels part science and part magic. It begins with glass tubes that look plain and fragile. Skilled workers heat them with powerful flames until the glass becomes soft and bendable. Using just their breath and steady hands, they shape the tubes into letters, curves, or entire symbols. It's one of those moments where craftsmanship outshines automation, because no robot can match the smooth bends made by an experienced neon bender. Once the shapes are ready, the tubes are cleaned and prepared for the next step, the secret behind the glow. The inside of the glass is coated with phosphor powders, and then gases like neon or argon are added under carefully controlled pressure. When an electric current passes through, the gas lights up, and depending on which gas or coating is used, the result can be classic red, bright blue, or even vivid green. Watching a sign flicker on for the first time feels almost like lightning trapped inside glass. In some workshops, workers test the signs by dimming the lights and letting the glow spread across the room, making the shapes seem alive. What makes it even more incredible is that many of the techniques haven't changed much since the 1920s, when neon signs first lit up city streets. Despite the rise of LEDs, neon still holds a special place, because it has a warmth and vibrancy that digital screens can't fully copy. Walking past a glowing sign feels nostalgic and futuristic at the same time. almost like stepping into a scene from Blade Runner where light itself becomes part of the city's heartbeat. Seeing how these signs are made turns every glowing letter into a small work of science and art fused together. Glass marbles may look like simple childhood toys, but their production is one of the most visually captivating processes in the world of glasswork. It starts with raw glass melted in furnaces that reach temperatures over 2,000 degrees Fahrenheit. The glowing liquid flows like honey and is cut into small glowing blobs that will soon become marbles. These red-hot drops fall onto rolling tracks or into mechanical molds that spin them continuously, shaping them into perfectly round spheres. What makes the process hypnotic is the addition of color. Workers introduce tiny rods of colored glass or swirl pigments into the molten mass before it cools. As the sphere rolls and turns, those colors stretch and twist, creating the signature swirls, stripes, and patterns that make each marble unique. No two are exactly alike, which is why collectors around the world treasure them. After shaping, the marbles are cooled slowly in long annealing ovens to prevent cracking. Once hardened, they're sorted, polished, and graded for size and clarity. Some are destined for children's games, while others are made larger and more intricate, often used in art or engineering displays. Historically, marbles were once handmade by artisans who would snip and roll the glass with simple tools. But today, machines can produce thousands every hour, each one glowing as it drops from the production line. Watching hundreds of marbles form and tumble down chutes looks like a colorful waterfall of glass gems. The result is more than a toy. It's a reminder of how heat, motion, and artistry can transform molten glass into objects that have fascinated people for centuries. Seeing the process in action is as mesmerizing as watching a kaleidoscope being built in real time, with fire and glass dancing together. A pencil may look ordinary, but the way it's made is anything but simple. The journey begins with graphite, which isn't pure lead as many still believe. It's actually a blend of ground graphite powder and clay, mixed with water until it forms a thick paste. This mixture is pushed through machines that extrude it into long, thin rods that look like spaghetti made of stone. After drying and firing in hot kilns, these rods become the familiar dark cores that give pencils their writing power. Meanwhile, lumber mills prepare the wooden casings, usually from cedar because it cuts smoothly and has a pleasant scent. Large boards are cut into thin slats, and grooves are carved into them to hold the graphite cores. Workers or machines then lay dozens of graphite rods neatly into the grooves, before sealing them with another grooved board on top, like a wooden sandwich. This block is pressed together with glue, dried, and later sliced into individual pencils. What makes the process fascinating is how precise it has to be. Every pencil must be straight, smooth, and sturdy enough to sharpen without splintering. After cutting, the pencils are shaped into their classic round, hexagonal, or even triangular designs by rolling them through special cutters. The next stage brings color and branding. The raw wooden bodies are dipped in paint baths, dried in long lines, and coated again until they gleam with the bright yellow, red, or black finishes we all recognize. Finally, erasers are attached with tiny metal ferrules, and logos are stamped in gold or black foil. Watching all these steps come together shows that something as small as a pencil is a result of dozens of intricate stages, each perfected over centuries. From clay and cedar to the finished tool in your hand, the pencil is proof that even the simplest objects hide incredible production stories. Turning ordinary sand into flawless sheets of glass is a process that feels almost magical when you see it unfold. The story begins with silica sand, one of the most common minerals on Earth. In massive furnaces that roar at over 3,000 degrees Fahrenheit, this sand is mixed with soda ash and limestone until it melts into a glowing orange liquid. At this stage, it looks like lava, bubbling and shimmering with heat. The molten glass is then carefully poured onto a bed of molten tin in what's known as the float process. Because tin is denser, the glass spreads across its surface like oil on water, forming a perfectly flat sheet without a single ripple. This invention revolutionized glassmaking in the 20th century, making it possible to produce flawless windows on a huge scale. As the glass floats, it slowly moves through controlled heating zones that gradually cool it, locking in strength and transparency. The sheet stretches forward like an endless ribbon, sometimes more than 10 feet wide, until massive rollers guide it toward giant cutters that slice it into perfect panels. Factories can produce miles of this material every day, destined for skyscraper windows, car windshields, and even smartphone screens. Watching it happen is hypnotic. The fiery river transforms into a crystal clear surface right before your eyes. What makes it even more impressive is the precision. A difference of just a few degrees or a tiny impurity can ruin the entire sheet. Engineers monitor every second using lasers and cameras to ensure the quality stays flawless. From gritty sand to gleaming glass, the journey shows how one of the planet's simplest materials can be transformed into something that shapes the modern world. It's not just science, it's industrial artistry on a breathtaking scale. Soap might feel like one of the most ordinary items at home, yet watching it being produced in factories is almost hypnotic. The process starts with massive steel vats where fats and oils are blended with lye and water, creating a thick mixture that slowly cooks until it becomes a smooth base. Once the mixture is ready, it's poured into molds or pushed through giant machines that shape it into long, heavy blocks. These blocks can weigh hundreds of pounds and look more like slabs of cheese than something meant for washing. Then comes the most satisfying part, the cutting. Huge wires, blades, or rotating slicers glide through the blocks with perfect precision, dividing them into dozens or even hundreds of identical bars in a single pass. The slices are clean, sharp, and surprisingly smooth, almost like cutting butter. Some factories even use machines that push the soap through patterned molds, stamping each bar instantly with a brand name or design. Watching this in action is a bit like seeing dominoes fall in slow motion. Rows of perfect bars appear one after another, stacking neatly for packaging. What makes the process especially captivating is the speed in some modern facilities. Thousands of bars can be cut, wrapped, and boxed within minutes. At the same time, the colors and scents being added to the soap, whether bright swirls, natural herbs, or rich perfumes, make the production line feel like a mix of science and artistry. Every single bar that ends up in a bathroom or kitchen sink goes through this carefully engineered routine. Seeing it behind the scenes changes the way you look at soap forever. It's not just a cleaning product, it's a small piece of engineering shaped with incredible precision. Concrete bricks might seem basic, yet the way they are made by hand is both satisfying and impressive. In many small-scale factories and workshops, workers start with a mixture of cement, sand, gravel, and water, blended into a thick slurry. Unlike giant automated plants, here the process is all about human precision and skill. The wet concrete is poured into sturdy molds that are either metal or heavy plastic, shaped to create uniform bricks. Workers spread the mixture evenly, tapping the molds or using vibrating tables so every tiny air bubble rises out, leaving the surface compact and smooth. Once the molds are filled, they are leveled off with tools, giving each brick sharp, clean edges. What makes this process fascinating is that it's a perfect combination of strength and artistry. Some workshops even add pigments, creating red, yellow, or black bricks, which gives construction projects their signature look. After setting for a short time, the bricks are carefully removed from the molds, lined up in neat rows, and left to cure. Instead of relying only on ovens or machines, natural curing is often used. Bricks are sprayed with water over several days so they harden slowly and evenly. The sight of hundreds of fresh bricks, still damp and glistening in the sun, is strangely captivating. Each one looks almost identical, yet every brick carries subtle signs of the hands and techniques that shaped it. This handmade approach has been used for centuries. And even with modern automation, it remains common because it's affordable, flexible, and reliable. Watching raw concrete turn into building blocks of houses, schools, or streets in a matter of hours gives you a new respect for how something so simple underpins entire cities. It's a production process that shows strength being crafted step by step, one brick at a time. The transformation of trees into enormous rolls of paper is one of the most striking industrial processes to witness. It begins deep in the forest, where logs are harvested and transported to pulp mills. Once they arrive, bark is stripped away, and the wood is chipped into small, uniform pieces. These chips are then boiled with water and special chemicals inside massive digesters that tower several stories high. After hours of cooking, the fibers separate into a wet pulp that looks nothing like wood anymore. This pulp is washed, bleached until it becomes bright white, and screened to remove any impurities. At this stage, it's like thick porridge. The pulp is then poured onto moving mesh conveyors where water drains away and the fibers begin bonding into thin sheets. What makes the process incredible is the scale. The sheets stretch longer than football fields as they move through giant rollers that squeeze out more water and dry them with steam-heated cylinders. By the end, the fragile pulp has transformed into sturdy, continuous paper. Finally, colossal machines wind the finished sheets into rolls that can weigh several tons each and measure over 30 feet wide. Standing beside one of these rolls makes you realize just how massive everyday production really is. From there, the rolls are shipped to printing plants or cut down into notebooks, printer paper, packaging, or newspapers. The journey from solid tree trunk to delicate sheet is a reminder of how engineering and chemistry can completely reinvent raw materials. Watching it in action feels like seeing nature and technology merge, forests turned into rivers of white sheets gliding smoothly through machines, ultimately forming something we use every single day without thinking twice. Chocolate is one of the world's favorite treats, but seeing how it's produced in factories takes the appreciation to another level. It all begins with cocoa beans harvested from tropical regions. The beans are fermented, dried, and roasted until their aroma fills the air. After roasting, they're cracked open to remove the shells, leaving behind the rich cocoa nibs. These nibs are ground into a thick, dark paste known as cocoa liquor, which already tastes like unsweetened chocolate. What makes the industrial process fascinating is how this raw paste is transformed into silky bars. The cocoa mass is pressed to separate cocoa butter from cocoa solids, and then both are recombined in precise proportions with sugar and milk powder, depending on the type of chocolate being made. Massive mixers knead the blend until it becomes smooth, and then it enters the stage known as conching. During conching, giant heated rollers stir the chocolate for hours or even days, breaking down tiny particles and releasing the rich aroma we associate with finished chocolate. The result is a glossy liquid that flows like velvet. Another critical step is tempering, where the chocolate is cooled and reheated carefully so it hardens with a perfect snap and a shiny finish. Factories then pour the liquid into molds that vibrate gently to remove bubbles, before sending them through long cooling tunnels. By the end, the molds flip and release flawless chocolate bars ready for wrapping. Watching the production line is mesmerizing. Thousands of bars glide by on conveyor belts, each identical, yet each carrying the result of centuries of refining the craft. Whether it's a simple milk bar or a luxury dark slab, the journey from bitter beans to smooth, melt-in-your-mouth chocolate is one of the most enchanting production processes you can witness. Turning old plastic bottles into soft clothing is one of the most surprising recycling processes to watch. It begins with mountains of used bottles collected from cities and beaches, which are sorted by color and type. After the caps and labels are stripped away, the bottles are fed into giant shredders that chop them into tiny flakes. These flakes are then washed thoroughly to remove any residue before moving on to high-temperature dryers that leave them crisp and clean. The real magic happens when the flakes are melted down into a thick liquid and pushed through fine nozzles, almost like a pasta machine. Instead of spaghetti, though, what comes out are thin, continuous strands of polyester fiber. These threads cool quickly and are stretched to make them stronger and smoother, before being wound into huge spools. At this stage, the material already feels like something you could weave into fabric. Factories spin and twist the fibers into yarn, which is then knitted or woven into textiles used for jackets, sportswear, backpacks, and even shoes. What's amazing is that the end result feels nothing like the crinkly plastic it came from. A soft hoodie made this way can actually start its life as dozens of discarded bottles. This process not only reduces plastic waste, but also shows how innovation can give new life to something once considered trash. Seeing the production line in action is oddly satisfying. Bottles go in one end, and rolls of fabric come out the other, ready to be cut and stitched into everyday clothes. It's a transformation that feels both futuristic and practical, proving that sustainability and style can go hand in hand. Watching plastic turn into fabric feels like witnessing a real-life alchemy for the modern world. Few production processes capture raw power like steel forging. Inside giant workshops, furnaces roar as steel bars are heated until they glow a blazing orange, reaching temperatures over 2,000 degrees Fahrenheit. The sight of these molten hot pieces being pulled from the fire is both intimidating and captivating. Workers and machines move them quickly to massive hydraulic presses or hammering machines that shape the steel with crushing force. Each strike sends sparks flying in brilliant showers, lighting up the factory floor like a fireworks display. Forging isn't just about brute strength, it's about precision. The metal has to be shaped while it's still hot and flexible, with every hit carefully timed to avoid cracks or weak spots. Watching a giant press squeeze a glowing block into gears, shafts, or blades is like seeing clay sculpting on an industrial scale. What makes it even more incredible is the control. Despite the violent hammering, the finished parts must meet exact measurements down to a fraction of an inch. Modern factories often use computer systems to monitor every strike, blending centuries-old methods with cutting-edge technology. The result is components strong enough to handle jet engines, bridges, and skyscrapers. Once the steel has been forged into shape, it goes through controlled cooling and additional treatments to harden it further. The contrast between glowing fire and the slow hiss of cooling water adds to the spectacle. Watching steel forging is like stepping into a scene from a fantasy epic, where blacksmiths shape weapons of legend, except now the weapons are turbine blades and machine parts that keep modern life running. It's one of those production processes that feels both ancient and futuristic, showing how fire and force can turn raw material into the backbone of civilization. Factory pasta production is one of those processes that's oddly satisfying to watch. It starts with huge mixers blending semolina flour and water into a dense dough. Instead of being rolled by hand, the dough is forced through massive extruders that push it through bronze or Teflon dies shaped like penne, fusilli, or spaghetti. The pasta emerges in endless streams, perfectly shaped and cut by fast-moving blades. It's mesmerizing to see spaghetti pouring out like golden hair or penny tubes falling in neat cascades. Once shaped, the pasta travels through giant dryers that use carefully controlled heat and air to lock in texture and shelf life. The result is mountains of pasta moving along conveyor belts, ready to be boxed. The scale is incredible. Factories can produce thousands of pounds every hour, yet every piece looks uniform. Watching this flow of shapes feels almost like a food version of an assembly line ballet, turning flour and water into one of the most beloved dishes on Earth. That's about it. Which production process surprised you the most? Write in the comments. For more useful information, watch other videos.